Namaste. Welcome to AndroIdiots Podcast. I am Anupam Singh.
I am Tushar Gupta. We talk about what's new in Android, best practices, and how to be a better Android developer.
Okay, Tushar. Today we're discussing something which is very simple. It is much ignored and it is very useful. And it's something which differentiates an amateur developer from a good one, which is memory leak. And today we have Jupneet with us and he'll shed light on the same.
So, Jupneet, would you tell our listeners a bit about memory leak, what exactly it is?
Hi guys. So a memory leak is nothing but when you hold on to an object, but the object is not required. Its purpose has been served. So just holding onto that object and it's not required. That particular situation is nothing but a memory leak. For example, you must have used static views. Better than that, there is an example of if you register a listener and you forget to unregister the listener, and that can cause a leak because it didn't have the reference.
Yeah, that's actually very common.
It's a very common use case, yeah. For maps we do that, I think for a lot of callback things we do that. So for music system services we do that.
So why should a developer worry about memory leaks? Doesn't Java's garbage collector takes care of it, all this?
Yeah, it does, but it's basically, so it's kind of utility that you already have. You don't have to worry about, you used to worry about alloc and alloc and C. But if you are not using it properly, if you are making logical mistakes in your code and you're not abiding by the normal structure of Java, so then it won't be of help. Because so if I dig into garbage collector, so it has like two types of, so Dalvik is the JVM that we're talking about. So it has two types of garbage collection things. One is concurrent and one is for alloc. So GC concurrent and GC for alloc basically. So in one frame is I think for about 16 milliseconds. And when GC concurrent runs, it runs for twice for like 5 milliseconds. So it drops a frame, but it doesn't affect, you won't recognize it on the device. So that's why it runs smoothly. So it's a drop. But there is one thing which is very important to note is there is a second type of garbage collection which is alert. And that is actually, it stops the main thread for like 125 milliseconds. So that's quite a glitch that you actually see in applications. So it's very important for us to know these statements, these facts when we get memory leaks, because this is what is happening internally. So when you say Java is already giving you garbage collector and why still memory leaks are happening, I would say that you are not properly utilizing that thing.
So, okay, Jupneet, what is the difference between the concurrent GC and the alloc GC?
So basically, first of all, garbage collector runs when the heap is constantly increasing and it has to clear out the heap. So if everything is going fine, there is no leak. So in that case, first you try the concurrent part because it's very easy and it runs on a separate thread. But if you have a lot of memory leaks going on in the application, a lot is going under the hood, then you will go for this alloc part because this actually holds the thread for it stops everything. There's a term called stop the world GC pausing. Okay. So basically that runs and that actually the entire application which runs on the main thread, and the main thread is there, so it stops that thread for like 100 milliseconds around, something like that. That's a glitch that actually people observe because it drops a lot of frames for the user. And in the concurrent part, you don't observe the glitches because they're very smooth and they're not that glitchy, So the frames are dropped, but you won't notice it.
So this alloc garbage collector comes into picture only when there is a memory leak, or it runs even if you have like excessive memory usage in your app?
So I think when there is a lot of memory being consumed in the heap at that part, because garbage collectors keeps trying to give memory to the app. It keeps cleaning the app, and when it sees that there's a lot going on, only then this thing happens.
Yeah.
Because now it has to clear a lot.
So, okay, Jupneet, let's say in layman terms, how do you explain how the GC works?
In your application, there has to be a first object, right? There has to be one object which instantiates another, and there is a chain which goes on, which references one, and then first reference is 0, second reference is 1, and so on. So you can say the first object that you made, it is the root of the tree. The tree is there, and how garbage collector works is, so every node of the tree is an object, right? And it's referencing to another, and so on, the chain is being made. So how garbage collector works is it will traverse the whole tree, and whatever node that has not been traversed for garbage collector, so it's a dead object. And garbage collector is there to clean those dead objects and free up computer.
So Jupneet, we are all Android developers here, right? So every day we write a lot of Android code in Java or in Kotlin. and there's a lot we use, like async tasks. Then there are different architectures we follow. So like what are possible cases where we might leak memory in Android?
So I think it's a very very big question.
Yeah.
So I think we can segregate this into 6 or 7 categories. I don't know. Let's see how much we can. So let me start with a very basic. I think there are static views that we make. So first of all, static memory it's different from dynamic memory, right? Because it remains in the whatever you instantiate in static memory, it will be there for the lifetime of the application. So let's say if you are trying to make a view and you feel that okay, instantiating this view is very difficult because it's a big process, and you try to make that view static. So before that, I would have to go to one point because the activity object has the references to your artist, right? So whatever you fit in that view hierarchy, it will automatically have the reference to the activity. So if you try to make one view static, that means that will automatically has the reference to the activity that it's in the view hierarchy of. So don't make view static, because if you make view static, it will automatically leak the memory for the activity. And activity leaking an activity, man, it's a very very big thing because it's a huge object. It has the variable, apart from all those things, it has like hierarchy, it has tons of things. It's one of the biggest objects in Android.
Yeah, that's why it's also called God object.
God.
Android.
And so what else? Is it so? What are the other ways I can leak memory?
Okay, so one was the static views. Then I've also seen some people, just whatever activity they are, like activity A, so they actually make a static variable and store the activity in that variable. So again, it will leak the memory for that.
So static variables are a big no-no because static memory will never be cleared. So
yes.
Whatever you put in static, whether it's an activity.
Just observe that you are not, directly pointing or indirectly pointing to the activity, and that's a static variable. Okay, that's very important to know. Apart from that, we have very common cases of the anonymous classes, and example would be of async task that we have used. So what happens is, if you make an anonymous async task, it will implicitly have the reference to the activity which is defined. And so how it's going to leak the memory is basically, let's say if you define the async task and it's doing its job, and by the time it's doing its job, you call on destroy of the activity. So that's nothing but the natural life cycle of the activity, right? So again, for you, it has been destroyed. Right? According to your logical interpretation, it has been destroyed, but the reference to the activity is still there in that async task. And if you remember the memory tree, if we go by the root, and there will be a reference for that activity, right? Because that async task is still holding the reference to that. So garbage collector will traverse it because it will know okay, this has a reference. Again, that's exactly where memory leak is. Not required, but still there. And there is one more common case that which happens is you try to load something in the background and you rotate the device. So if you rotate the device, what happens? The activity is on destroyed and it's again
it's recreated.
Right, it's rebuilt. So that's happened again. If an async task is happening in the background, so you can leak the memory of the device.
So Jupneet, what I understand is, if you have an async task inside an activity, which is basically making a big DB call or a network call, suppose, and for some reason the activity is killed. Suppose even if user presses the back button, the activity is killed. But actually, the DB call or the network call might take a lot of time to complete, and that's because of that async task will not be killed. And since async task is holding to the activity in itself will not be killed. That's a memory leak.
Yeah, in terms of memory, it will be there. But if your async task has done, it's done, so nothing.
Okay, got it.
Okay, so Jupneet, it's very common that we write a lot of multi-threading code also, right? So there can be it's very common that we leak memory while writing multi-threading code.
So it's quite possible because a lot of time the first thing that comes to mind is runnable objects. You make a lot of tasks in runnable objects, anonymous runnable objects.
Right.
So basically, we make an anonymous runnable object and give it to the handler, it gives to the queue and all that. So it schedules that okay, if you want to add a post delay or do it also and so on. So as long as the exact runnable code is not handled, it will keep holding the reference to that code. So if it's handled, then it's fine. But if it's not handled, if it's not run, and if you destroy the activity before, again it will be a leak.
So the sample would be, let's say, if I put in a post delay of let's say 200 milliseconds or
Or like 2 minutes. For example, let's say the worst case is like you want to run something after 60 seconds, 30 seconds, or whatever.
and by the time user kills the app, so that will create a memory. Okay. So what else in multi-threading?
So there is the same pattern you can actually replicate it in terms of threads. And timer tasks, these are very common. Timer tasks. The same pattern actually replicates to these.
So what I understand here is, so whenever I'm writing a multi-threading code, I need to make sure that the life cycle or the lifetime of that thread that I'm running in the background has to end whenever the activity ends, right?
Yeah, you have to calculate things properly.
Okay, cool.
Okay, so one more thing I would like to add over here is about the concept of inner classes. So the basic fundamental of inner classes is that it holds implicitly it holds the reference to the outer class. So let's say if we define an inner class in an activity. So one of the purposes is also to improve the readability of the code and encapsulation. That's why we mostly also make inner classes. So if you do that, then by default it's referencing the activity, and let's say if you make a static reference to that inner class. If you do that, again keeping the memory and you keep holding the reference to the activity, so it's going to create a new.
So Jupneet, we use a lot of Android APIs, right? So there are like a lot of system services like location
Absolutely.
sensor managers. So like, do we need to take care of something while using those APIs?
Yeah, definitely. Because so whenever you say call get system service, that's the name of the call, get system service, and then you specify sensor manager or whatever you want to have from the system. So what happens in that is all these system services, they are running their own process, right? So if you say you want that service to be used, you actually register over there as a listener. Okay, so your context is over there, you register over there as a listener, and whatever, let's say if you want whatever service you want, if something happens related to that service, it's the responsibility of that service to notify you.
Yeah.
So if it does, then it's fine. If you forget to unregister it, then there's a big negativity because the context is leaked.
Because the activities context is with the service.
Yeah, because you register over there, right?
Yeah.
You register as a listener over there. So it has to notify you. So it's going to be a big leak.
Okay.
If you don't unregister it.
So that service will hold the reference of my activity or my context for a long time.
Exactly, because you do not unregister it.
So Jupneet, very common case is images, right? See, all our apps are image intensive. We populate a lot of our images in our apps, be it say landing screen of the app or be a say product SKU screen of the app.
There are a lot of lists and all that.
So there are a lot of lists, there are a lot of images. So as an Android developer, what should I keep in mind so that I don't leak a memory while handling images?
Yeah, so images are very important when it comes to Android apps because we use it like everywhere, splash screen and lists beside it. Yeah, so bitmap basically is nothing but the object is quite heavy itself because it has all the pixel data of the image, and we should be very careful when we are dealing with images because we need to take care of the fact that we should reuse as much as possible because they are heavy memory intensive. And one of the ways is I think bitmap pooling. It's very effective because it keeps on reusing the memory as much as possible, and what happens is whenever you allocate and deallocate memory, the GC call is there, we have to just avoid calling GC as much as possible. We should not be calling GC. It's a good tool to have, but again, we have to make sure that we don't exploit that, right? Because eventually it will make your app slower because it will drop frames and the experience won't be smooth, especially in the case of when you scroll the lists in which there are a lot of images. In every list item there is an image or two. Then it will be if you don't use bitmap pooling and you will load every image, it's going to be a disaster, I think. Because especially if the images are heavy, then there will be a lot of glitches. You must have observed also in some of the apps there are glitches when you scroll.
Yeah.
So I don't think they are using proper utilization. So what happens is we have to avoid frequent calling GC, and an example of bitmap pooling would be, let's say you have bitmap 1 and you used it, and now there is bitmap 2 that you want to use, but what will happen is it won't recycle it because recycling again involves calling GC. It will reuse the memory that was there for bitmap 1, and so the memory would be given. But you have to be sure that it's safe to do that. It depends on the use case. You have to be sure that it's safe to do that. And for that I think you can use the library Glide. I have used it. I actually benchmarked that library against Picasso and It's been a while. So I think Glide would be a perfect choice because it has a lot of features for you. And it takes care of these things automatically. And plus one more thing that Glide handles is use the exact size of image wherever you want to use the image. Don't use the full size image where you just want a thumbnail. Okay, just one last thing.
Yeah, that's cool.
So Jupneet, once the developer is done from his end, right? So we usually assume that our code is going to memory leak free, right? So at the end, is there any tool or something which we can use to identify those memory leaks if they are present?
Yeah, there's a very famous tool which has like 20,000 plus stars on GitHub. That's a library called Leak Canary by Square. It's a very, very famous library. And they actually show you the trace also that where exactly is the leak with the objects and also it's a good tool to. So when you can actually use it while you are writing the code also. But like you mentioned, you're done from your end. You can definitely give it a run. Let's run Leak Canary on the project and see if there are leaks. But I think we should use it as we develop, so things are not piled up.
Okay, Tushar, we covered a lot of topics today, from how GC works, from how we can unknowingly create memory leaks, and various ways to avoid them, right?
Yep, and once Benjamin Franklin said, a small leak will sink a great ship.
That's right.
Yeah, that's true.
So thanks, Jupneet. It was a great session. We learned a lot today. I hope we have you another day for another podcast, and it will be great hosting you. Cheers.
Cheers.